Hey guys, this is Kendall Terry, and this is AP Biology looking at chemistry and life. And when I think of chemistry, I don't think of chemistry like this. I think of chemistry like this. Now that we're ready, let's talk about some very basics of chemistry and what goes on. And to do that, I'm just going to use this board right here behind me. So when we look at chemistry, let me find my marker. There it is. When we look at chemistry, what we're looking at then is elements. And the most common element that we look at in biology is carbon. And carbon, we say, has an atomic number of 6. And what that means is it has 6 protons, which also means that it has 6 electrons. We'll talk about electrons in a minute. And when we look at the atomic mass of carbon, we find out that it has an atomic mass of, we usually round it to 12. Now, that means that there are 6 protons in the atom and 6 neutrons. Neutrons also have an atomic mass unit of 1. Now, we round this because there are other isotopes of carbon floating around out there in nature that have different numbers of neutrons, but the most common one that we talk about has 6 neutrons in the nucleus of the atom. So we're looking then at the electrons that are in play. Then it has 2 electrons right here in the first energy level, and that leaves 4 more electrons. So we put them in an outer energy level. But when we look at the outer energy level of an element, it doesn't want 4, it wants 8. So this outer energy level here wants 8 electrons, and it currently only has 4. So what that allows it to do is create bonds. And the bonds that carbon creates most often are covalent bonds. And covalent bonds means that it shares an electron. And the most common one that it shares with for biology is hydrogen. So when it's sharing a hydrogen, it will share an electron with the hydrogen, and the carbon will share an electron. They'll share back and forth. So you've got an equal sharing, and this creates a nonpolar molecule, meaning it doesn't have any charge. Okay, this is just methane gas, and these are all what we call covalent bonds. Okay, now another very important one that we look at in biology is oxygen. And oxygen has 8 protons with 8 electrons. So if you put 2 electrons in the first energy level, that leaves 6 electrons in that second energy level, so it wants 2. And it has a little bit stronger of an attraction for these, and the most common element that it will bind with as well in nature, oxygen binds with a lot of stuff, it's very reactive. It will bind with hydrogens. This creates the molecule that we look at a lot in life, and that's water. So with water, it also has this sharing of electrons, but it's a little bit unequal sharing. The electrons actually hang out more here than they do up here with the hydrogens, and that gives the oxygen a negative charge, and it gives the hydrogens a positive charge, and this creates what we call a polar molecule. A polar, it's got polar charges, a negative side and a positive side. And so when you put a bunch of water molecules together, what they do then is they will attract each other. So here you've got this hydrogen that's a little bit more positive, and this oxygen that's a little bit more negative, and you've got an attraction that'll happen here. And when this hydrogen is attracted here, sometimes that causes this hydrogen to attract to another water molecule, and this creates what we call hydrogen bonding. And those hydrogen bonds are weak bonds, but they're very important bonds to biology and what we do. Another very important bond in biology is what we call ionic bonding. And ionic bonding is molecules like, for instance, sodium chloride, NaCl. And sodium chloride, you've got the sodium that wants to get rid of an electron, and the chlorine that wants to gain an electron. This is just table salt. It will donate its electron to chlorine. So now chlorine's got an extra electron, and it becomes negative. Sodium's missing an electron, it becomes positive, and opposites attract, right? And that is an ionic bond, when opposites attract to each other. So that just gives you a little background of some chemistry that we use in biology, and we'll be doing some more stuff in class with it.